Hi, ladies and gentlemen. This is Kev at Nadespam. I'm just going to talk about the random dungeon generation that I've been working on for the game that I'm currently working on, temporarily being called Delver's Guild. I don't have a final name for it yet, but anyway, the game is going to be a role-playing game, co-op multiplayer with dedicated server, and I'm designing it to be a bit in the vein of Daggerfall, the older Elder Scrolls, taking a lot from Dungeons and Dragons, and actually quite a bit from Arx Fatalis. I think a lot of influence from that. So one of the backbones of the game design is going to be randomly generated dungeons. But one of the challenges I have been facing during this is that I don't want to do real-time roguelike random dungeons. I want to be able to generate them directly ahead of time in the editor that I've been working with, Unreal Engine 4, and to be able to curate those dungeons once they're generated. Because I think, as everybody who has played roguelikes in the last few years knows, you get at least some boring, repetitive content, even with the best dungeon generators. In fact, if you go farther back, you probably start getting better stuff with older generators and games like NetHack. I don't know, I didn't play a lot of games like that, so I'm just going to jump into what I'm actually doing here. I'm actually using something called Blutilities in Unreal Engine 4, which I did not know of until just recently when I was working on this. They're fantastic. They'll let you write scripts that will affect the editor, add buttons into the editor, which I have not done yet, but lots of people working on this engine probably already know about them. But if you don't, check them out because they're pretty great. Previously, I'd been using the constructor in one of the objects I created for this, and there's a lot of limitations, especially when it comes down to editing the objects once they're spawned. The constructor really can only add subcomponents to that original base actor that I found, and if you move or change anything at all, everything's going to, the constructor gets rerun. There's no way to like turn it off and just leave it with what you've got, even if you detach it from the actor that I found. So using Blutilities, here is an example of a dungeon generated, and actually I did a few different things on top of that as well. I've added some scripting utilities to continue to add additional hallways and rooms. So why don't we go ahead and show how it actually works. I've got a little script to just delete all those chunk actors, and let's go ahead and let's feed it some numbers. So like 25 rooms, 25 hallways. It lets you input a grid size, so you can use a different amount of movement. The general algorithm starts off at 0 on the map and just builds things and then bubbles the rooms outwards. There's other algorithms that I've looked at online that do something similar in 2D. This one, it was actually really hard to get working with that third dimension, but yeah, here we go. So it does take a few seconds, and there's a whole bunch of log spam you can see. And what it does is it creates these various dungeon rooms. Here's some examples of which I've only got a couple in there right now while I've been getting this to work. So it does that, and then it tries to connect the nodes in each room to each other via hallways. And it's not quite perfect even now. I've got maybe 2 or 3 weeks of casual work on this. You see, you kind of get this like half off effect sometimes where it thinks it's going to reach it with the hallway and it doesn't quite get there, but that's okay. Again, the part of the I wanted it to be able to be curated as well, and there's definitely a certain level of it's good enough that I'm I think approaching where it's not worth putting another, you know, however many hours in just to get like a little bit better performance or a little bit better not performance, but accuracy with where it's placing this. You know, like here's this section here it's separate here. It's easy enough to just slide that over, and hey, it works. One of the interesting things about the main game that is inspiring this work is that Daggerfall has thousands of dungeons, thousands. So I'm not quite aiming for that number, you know, maybe 1 to 200 fully randomly generated. You know, 100 might be pushing it, but so I'm not super concerned with it getting exactly perfect every time it's generated. If it gets close, and then I can clean up issues with it, I don't really have a problem with that right now. Of course, it will continue to be a work in progress as I work on the game itself, so maybe I'll get it to the point where it is perfect at lining those up. So anyway, you can see there's a bunch of different rooms. There's some hallways. Some of them didn't end up getting connected. Some of these they're like a half a point off. I've actually got it at a grid of about 1,000 right now. So you see some of these are sort of half a point off. So they don't really want to quite connect. But one of the things that I've added is the ability to move things around and have it go back in and make more hallways. And one of those is very specifically tries to make perfect fits. So here's one right here. So we lined it up a little bit better. It went in and made a perfect fit hallway. That's a hallway that's designed to, you know, in this case, move forward one and go up one. And that fills it in a little bit better. The other thing I did today, in the last couple of days here, is add the ability to add additional random hallways that are just going to kind of spawn off, and it's hard to tell exactly what's a hall here, but you can see things were added. So it'll add additional hallways wherever, just aiming off into the nothing, into the void. And let's do that one more time so we can kind of see. Oh, okay. So one thing I've noticed with the Blutility is sometimes if you run it multiple times, it doesn't like to keep working, and you have to close that and reopen it. I'm not quite sure what the deal is with that, but here, we'll make some more halls. And this one takes a little while. This might actually be the majority of the time that it takes to generate a random dungeon. Oh, I made the wrong one, didn't I? Clicked the wrong one. That's okay. So let's make random halls again. And you can see it keeps filling things in more. We get more hallways here and there, and some of these there's actually a whole lot of. It looks like a lot of hall here. These I've filled in with a block, so you can kind of see it from outside. Once we do a little bit more, I'll actually open that up so we can see what they look like inside right now. And then I've also got a random room generator. It's just going to try to tag rooms on to the outside anywhere it can fit them. And this one takes a little bit longer. So something appeared here. You usually don't see as many, even if you tell it to do a whole bunch. It has more, you know, there's fewer places that the rooms can actually fit depending on the size of the rooms. And part of this, the engine here that I built to do this can take basically any size room that you want to build. Here's the examples that I've used. There's a little bit of work that you need to do inside of each object itself in order to get it to work properly. But basically any hall size, any hall length, and any room size, this can work with. So let's open it up real quick here. I'm going to open up the object that this works on. Let's turn off this block that represents the chunk itself. So this does work on basically on a grid of 1,000 square blocks. And yeah, here, now we can actually see, here's the hallways, and the rooms themselves. Again, these are just kind of placeholder graphics for now. You can see there's a whole bunch of, I've got like debug information printed off here that I was working with while I was trying to get the algorithms to place these rooms properly. I did have quite a bit of trouble figuring out how to get things lined up properly, as I haven't done a lot of vector math. But so far it's working pretty well. It's like you can see it's connecting rooms, connecting nodes. It looks very open because these chunks don't really have their full walls yet, but you can get a bit of an idea of how expansive this can create, you know, a large expansive dungeon with not a whole lot of time. You just click a couple of buttons with the base stuff I've got set up here. And some of these look kind of strange. Like here's actually a kind of a vertical hallway. So it's got this hall that we generated off of it as well. It doesn't go anywhere, but that's okay. One of the things I liked about, again, Daggerfall, it's going to be the main point of reference for me here, is the extensive dungeons that you absolutely could and would get lost in. There were, I think, some that were generated in that game that you either needed to be able to climb the walls or fly in order to actually escape from if you got too deep in. That you literally could go off of a cliff or down into a hole and you could be stuck and either have to reload a save game or have some way. The engine gave you ways to get out, but if your character wasn't built for it, it might be just too bad. And that's one of the things that I'm going to be focusing on: verticality, giving the players areas that are dangerous just because of how they're laid out, and being a co-op game, hopefully giving them different abilities where they'll have to work together in order to successfully traverse the various halls. So I'd like to talk a little bit about how I actually put this together. If you're watching this video, you're probably interested at least a little bit. So let me open up the spawner. And a lot of this probably could have been done a little bit more compact. There's probably a lot of repeated code here. This is really the first run at doing this, and I will admit right now I do regret doing the whole thing in blueprints. However, not completely. Some of again, most of the vector math is a lot easier to do in a blueprint, in my opinion. It's a lot easier to just grab nodes and hook it up and not fool around with trying to get everything laid out in C++. So from the top, there's 5 different functions built into this currently. Delete all just deletes all the chunks. Spawn a dungeon is the other main one, where it actually does the base dungeon generation. Once you've spawned it, you can fill in more perfect fit halls. I should probably rename this, but or make random halls or random rooms, and any combination. There's a number of variables you can feed in, like the grid size, verticality, and horizontality, which is probably not a word, but controlling whether it's going to be more vertically laid out or spread out horizontally. Room target count and hall target count, generally the number that they'll aim for. And some of these things, all these booleans down here play into the making random halls. Halls can initial spawning won't connect to each other at all. They just try to connect between rooms. Once we start adding more random halls or perfect halls, they can connect to each other and just fill it in a little bit more, so there's more go-betweens in between the rooms. So spawning a dungeon is pretty straightforward. We're going to go in and we're going to create a bunch of rooms. Once we've created those rooms, we're going to go create the hallways. Creating a room, again, I try to break this down a little bit. So you got like 20, 25 different functions at this point. Grabbing a random room, spawning the room, And then moving it until there's no overlap is where a lot of the logic happens. Initially, check overlap. If we've got it, if there is overlap, we're going to go into the loop here to start bubbling outwards. Bubbling outwards grabs a random direction. First, it starts off, it says, do we want to go vertical or horizontal in order to try to move outwards? After that, it will, if it goes vertical, it's going to go up or down. It's pretty straightforward. Otherwise, it goes in 8 different cardinal directions. And then sets the world location based on the direction that it's moving in. And something I built in a little bit later on in here is the ability to give it a larger movement or a random amount of movement. Instead of moving north one set of grid, 2,000 in this case, it can move anywhere from 2, 4, or 6,000. I think no, just 2 and 4. But you can give it different values in order to control how far it's going to move each time it finds it's overlapping something. So once we've done that, we check the overlap again, and if it fails to actually get itself out to an open location after 100 tries, which is quite a few actually, it's going to destroy itself. I don't think this is ever coming into play currently. If you told it to create a giant dungeon with 1,000 rooms or something like that, it would probably eventually kick in and it would just destroy some of those rooms, which is fine. And this is really the first piece I wanted to get working in this generator. So once it moves all of them out, it throws all those rooms into an array so we can keep track of those, and moves on to hallways. Hallways was a little bit more difficult than the rooms in that you've got to not only account for what's overlapping, but figuring out how to get from one room node to another room node, whether it can get there once it's placed. Oh, this is the old one. Once it's placed, whether or not it's now overlapping something that it didn't realize it was going to overlap. One big piece of this dungeon generation that I have not completed yet is the ability to chain together hallways in order to reach a destination. So that's a big piece that I would like to do, but so far haven't. So currently, the only way it can connect 2 rooms with a hallway is if I have a hull piece like here. Like this one, for example, is 3 long. If it can connect, if it can go straight forward 3 spots and reach another room, then this one can be used. If it would need to move 4, so maybe a 3 and a 1, don't have that working right now. Haven't quite started that yet. But so anyway, this actually will loop through every single connector or node in all of the rooms, and it will check every other connector. So it's gonna compare everything in the entire map to look for connections. Originally, I did just have it going out and randomly getting like 1,000 different tries or something like that. But I figure maybe I'll have both available at some point. But I really wanted to try to put every single potential match in there to begin with, and then from there I can go back and curate it down, and if we want more, add more hallways in, add some longer hallways. Otherwise, come back and trim some out and have fewer connections to give it more of a labyrinth and feel where maybe there's only a single loop through the whole thing, or maybe there's a bunch of random hallways off that lead nowhere, or that you give it more of that sort of confusing labyrinthian feel. So once it loops through all these things, the first thing it's going to do is check to see whether there's actually a path once it finds a connector. So it's comparing a base connector or working connector with a target connector. Draw a line between those, just a direct line, see if we have a direct open connection. If we don't, we're going to move on and try again. Once we've found two connectors that do essentially see each other with a straight line that doesn't pass through anything, we're going to find the path. So the path, again, because it's on basically a 3D grid, it's not too hard to figure out a real straightforward path. So we're looking at moves forward, moves left and right, and moves up and down. And then we set those and bring them back. And again, I've got a little bit of debug code here. So then we select and spawn a hallway based on this information. And this is where the split will happen between perfect fits and tagging or connecting multiple hallways together. But right now we just have perfect fits. So we go in here, we look for a perfect fit. And a lot of times you're not going to find one just because the halls I have available currently are not all that long. So if it finds one, it finds something, and that's looking out from a table. Unfortunately, one of the things I ran into using this is that there's not a good way to iterate through all the classes and look at the default values and whatnot. So I'm using a table to look those up right now. Not thrilled with that, but you know, the engine does have limitations. I may find a better way to do that at some point, but so once we get a perfect fit or two connectors that have a perfect fit between them, we want to move that hall to the node, and then we make sure we aren't actually overlapping anything else. This is mostly going to happen when we've got like a left turn or maybe a larger hall that's taking up multiple spaces. You know, maybe it detected there was a straight line between the two connectors, but there's an edge of something that we're actually overlapping now. If we overlap, we're going to destroy it and move on. So once that's done, once we've created all our halls, we're basically done. And then we can actually see the result. And again, just to show how that works one more time, we're going to create a new dungeon. So let's delete everything. Let's do a little bit of a bigger dungeon. Let's add 45 rooms and aim for like 100 hallways. And let's see how that works. I'm not sure if that's even going to work. It might take a minute here. So let's go ahead and spawn that up. It is actually a lot faster than the initial iterations I had of this. Early on, I actually had it freezing Unreal Engine because it was looping way too many loops. There is a maximum number of loops in the editor. Even if you change that number, I think it starts off at 1 million. You can kick it up to 10 million. That's not actually per loop. That's per function call. So if I kick off spawn a dungeon, if I end up running 10 million iterations of anything in total between all my loops, it's going to shut down. So this one, you can see it is quite a bit wider. I give it a little bit of a higher spread count, and as a result, we don't end up getting a lot of hallways. They move too far away for the perfect fit. So again, this is revealing one of the big pieces that I have not done in this generator, which is finding longer paths and stringing together multiple pieces of hallway. So definitely going to want to do that. And you see a lot of repeated rooms. Again, there's only 3 rooms right now. I've tried to design this to be as modular as possible, so I'll be able to do, you know, very large or very small rooms once I start designing those, as long as they're square or fit within a square. Which is not, you know, it's not a perfect solution. it would be nice if we could do weird, more realistic shaped rooms, and I'll probably end up doing some, but they're still going to prevent, if, for example, we had like a diagonal room or just a diagonally placed sort of hall style room, it's still going to end up taking up a square grid with the way this has been designed. And for the most part, I'm okay with that, just because it's making doing the hallway connections so much easier. I don't know how I would do that in 3D space without having an underlying grid. I just don't have the knowledge to do that. So I'm okay with this. Let's do it. Let's do that again. See if we can get something a little bit more dense. Let's up the room count a little bit, reduce the spread. I'm actually going to reduce the grid size from 2,000 to 1,000. Just to show off one more example of doing this. And I'm actually really surprised at how quick this is. Obviously, your results are going to vary. Yeah, this one's taking a little bit longer with 60 rooms, but actually, I wonder if that's going to time out. It's possible that because the hallway code will try to compare every single node in the map, that this is going to run over the loop limit. And yeah, that's exactly what happened. So I don't know. We got a few hallways. Yeah, we got less than 10 halls as a result, but that's okay. That's okay. We can up that number, but I'm not going to do that for this video. So that is the current state of my random dungeon generator. Again, set in Unreal Engine 4 for Delver's Guild, or whatever I end up naming it. It's a pretty bland name. So Project Delver's Guild. If there's any questions, go ahead and leave those in the comments. Hopefully I will be doing a video every week about the state of the technology that I'm working on, state of the game I'm working on, and actually start showing some stuff off as far as the gameplay and game design soon. So again, I'm Kev at Nate Spam, and thanks for watching.